All right, this is lesson 5 of Unit 1, Topic 1, and this lesson's about figuring out if the order matters when solving equations. And we start off with a warm-up that has to do with graphing equations and figure out whether or not this point is on this line. So the first thing I want to do is I want to graph that point. 1, 3 is right here. So now that I've graphed that point, now I'm going to graph this equation and then determine is that point on that equation. Or in other words, if I substitute this in for x and this in for y, would the equation be equal? Which will be another way of solving it as well. So 5x minus 2. So I noticed that negative 2 is the y-intercept, and the slope is 5, 1, 2, 3, 4, 5, which goes to the same point. And yes, it does cross that equation, so the answer was yes for the first one. For the second question, we got negative 2, 2, which is right here. And x plus 4. Plus 4 is the y-intercept, and the slope, which is 1. Because there's one x there, that means it has a slope of 1 over 1. Or you could say it has a slope of any number over itself, like 3 over 3. Up 1, 2, 3, right 1, 2, 3. Or you could do the opposite, down 1, 2, 3, left 1, 2, 3. And you're going to notice that this point does go on that line as well. So that works for the first two questions. Those are both yes is the answer. And then question number 3 is the only one I believe that is no. Negative 3, 0 is right here. Got to be precise right there. And x plus 2 means it starts here at 2. And the reason why I said you have to be precise is when you graph it, up 1, right 1, it's going to be very close, but not exactly on the line. So that one was the answer of no. So getting to this task, this was a story about lunches and how many trays there are in the lunch lines, and you have to, one of the strategies, ways of solving is to work backwards. Start at the end and do everything backwards using the opposite operation until you get the answer of 15 trays in each box, which we had done in class. And you could write that as an expression. You started off with 15 trays in each box. There are 4 boxes of trays, which makes 60 equal the amount of trays in all 4 boxes, and then you subtracted 24 to represent how many trays are taken away from the students in the line. And then the last thing that she did was she split what's left into 3 equal lines, which makes 12 per line, which is what it says in the story. So that's how that can be written out as an equation. And then we are determining, does the order matter? So what you notice about all 3 of these equations, A, B, and C, is that they all equal 12. They all have the exact same numbers, but they all require different steps in order to solve. Well, actually, they're the same steps, they happen to be in different order. So you're going to multiply this one times 3, and then divide by 2, and then subtract 4. It takes 3 steps. The next question is going to be divide by 2 and then multiply by 3 and then subtract 4. And then the last one is going to be multiply by 3 and then divide by 2 and then subtract 4. So it's the same steps to solve each question, just in a different order. And what you notice is that when you take 12 times 3 is 36, divided by 2 is 18, minus 4 is 14. You can show your work over here. Is what you're going to notice in the end is that you're going to get a different answer if you do the steps in a different order. 12 divided by 2 is 6. 6 times 3 is 18. 18 minus 4. Oh, maybe I did that wrong. 12 divided by 2 is 6. 6 times... Oh, this is the wrong order. Sorry. This would have been minus 4 first and then divide by 3. So as I try that again, so 12 divided by 2 is 6. 6 minus 4 is 2. 2 times 3 is 6. Different answer. This one, 12 times 3 is 36. 36 divided by 2 is 18. 18. Oh, okay. Times 3 would be the first step. Then subtract 4 would be the second step. And then divide by 2. That's what I get for rushing through this. I had the wrong steps. 12 times 3 is 36. Minus 4 is 32. Divided by 2 is 18. So you get a different answer also. All right. So same steps, just a different order, give you a different answer. So that was the objective for today, is to prove, we just justified that doing different steps gives you a different answer. And then last but not least, we have the homework. The homework is basically asking you to create your own equation that has this as the answer, n is negative 5. And we have at least one set of parentheses, and we want to have variables on both sides. N equals negative 5. So the first thing I'm going to do is add a variable to both sides. I'm going to add 2n to both sides. So that makes 3n on the left and 2n minus 5 on the right. So now we have variables on both sides, so I can check that off. The last thing we need to do is also have parentheses involved. So I'm going to divide everything on the right-hand side by 2. So we've got 3n equals, put a 2 on the outside. This is called factoring, which is something we're going to do later on in the year. 2 times n is 2n, and 2 times negative 2.5 would equal 5. Now I could have added 1 to both sides to make this an even number, so it would have worked out perfectly, but fractions will do. So now I've got parentheses and I got variables on both sides, and if I solve this equation, the answer is negative 5. So this does have the answer that we were looking for. Same thing goes for 3a, b, and c, but now we are trying to create a two-step equation, and we have to describe the properties that we have to use to solve it. So I can do anything I want to these questions, so I'm going to multiply both sides by 2. That makes 2x on the left and 6 on the right. So you can do anything you want. You can add, subtract, multiply, or divide. Just has to be 2 steps. So you need like a multiply and an add. So I'm going to add 3 to both sides. So that gives me 2x plus 3 on the left, and 6 plus 3 makes 9 on the right. All right, so there's a two-step equation. So I did multiplication, property of equality first. Okay, pen is not working so great, but you heard what I just said. And then I added 3 to both sides, so that's the addition property of equality. And there we go. And that's the justification that goes with that problem. So you can do the same thing for the other two. Basically, it's the exact same thing, just giving you a different starting point. Create a two-step equation. You can either add, subtract, multiply, or divide, and do 2 steps. Alrighty. Let me know if you have any questions. Thank you very much.